All right, there we go. Okay, so let's try 20 together here. So the first thing I would do on this is I would label what I have, right? So we've got A is 71, C is 20, and then we're supposed to solve for the other sides of this triangle. I'm not going to worry about the other angle. Let's just go for the other sides. So they call this side A and this one side B. Is side A the opposite, the adjacent, or the hypotenuse? Can you guys tell me that in the chat? Remember, I am counting the chat for participation, so you guys need to help me out there. So is this one is A opposite, adjacent, or hypotenuse in this picture? All right, it is opposite. Good. All right, we know that the 20 has to be our hypotenuse, and that makes the B the adjacent. All right, and if you need to label them in there, you need to label them in there, and that's okay. All right, so if I am going to solve for A, I have the opposite and I have the hypotenuse. Which trig ratio is that? Sine, cosine, or tangent? What do you guys think? Do we have sine, cosine, or tangent there? All right, I'm seeing a lot of sine. Good job. So sine of 71 equals A over 20. How do I move that 20? What do I have to do to move the 20? What operation do I need? We're not rationalizing yet. So what mathematical operation do I need? I am under division right now. So Angelica, revise your answer for me, okay, kiddo? All right, we are in fact going to multiply. There we go. So I've got 20 times the sine of 71 equals A. All right, so we're going to pop into Desmos. I'm going to put that into Desmos. I want to get the decimal point. How many decimal points are we supposed to keep according to Mrs. Ballard? How many decimal points does Mrs. Ballard always tell you? Good job. We've been listening. Good, good, good. All right, so we're in Desmos. I think I put the right numbers in. 20 sine of 71. Okay, there's a problem with Desmos though. I have to always double check my angle mode. What angle mode should I be in right now? Radians or degrees? What did we learn about earlier? Or actually, I guess it was last week. What rate mode should I be in? All right, good job. We should be in degrees, so I need to pop that to degrees. Once you get it there, if you don't like delete everything, it usually stays, but it doesn't hurt to keep checking it every so often. We will be converting. So the next lesson, the one you're going to work on your own, is going to start us converting to the radian measure. Okay. Once we get into calculus, we don't do anything but the radian measure. So right now you're in the transition phase. Okay. All right. So we've got 18.910 would be how we would round that. So A is 18.910. All right. We got to do B now. All right, so we got to find B. In order to find B, it looks like I have the adjacent, and I would go with the hypotenuse because A is a decimal point, so we wouldn't get as precise as we could with the hypotenuse. So adjacent and hypotenuse is which trig ratio? Can you guys tell me that in the chat, please? Which trig ratio is adjacent and hypotenuse? All right, we've got cosine. So we're going to do the cosine of 71 equals B over 20. Again, we would multiply that over. All right, and I'm going to pop into Desmos one more time. So 20 times the cosine of 71. I'm paranoid, so I double check. So it's in degrees, so we're good there. So 6.511. 6.511. Okay. That is the, what we're gonna, or what the, whatchamacallit, that's the little review, and you guys have convinced me that you actually are understanding that part. So that's good. That's the good news. We're gonna move into, I'm trying to find my notes on this so I can write these definitions the right way. All right, we're going to move into the next piece of this, which is angle of elevation and depression. Okay, I'm looking for my definitions really quick. So when you go into a building that's multiple stories, like more than your house, okay, 22 is 20, I think. Are you looking? You're looking at 21, Amy. We skipped this one. Okay. All right. I'm sorry. I just saw the chat. Okay. All right. Just want to make sure we're good. So when you go into a building, that is not your house. It's 2 stories or more. Okay. There's usually an elevator. When you go in on that ground floor and you push the button to the elevator, which direction are you going to end up going in the elevator? Can you guys tell me that in the chat, please? So which direction are you going to go on the elevator? All right, we are in fact going to go up if when we push the button initially on the elevator from the ground floor, right? So we are going to go up. Angle of elevation is the angle that goes up, but it goes up in a very specific manner. Okay, so let's write out the definition of this and you'll hopefully pick up on that. So this is the angle by which an observer's line of sight must be elevated from the horizontal to the point observed. So write that down and we'll talk about what that means. So for most of our purposes in this class, when we're doing these problems, we are going to assume our line of sight is coming out of our toes, okay? Because it makes our triangles more reasonable to work with, all right? So the line of sight is always the horizontal, and so we measure our angle up from that. So that makes the angle of elevation is up from a horizontal line of sight, okay? Again, the line of sight is going to be coming out of our toes. All right, our angle of depression. Okay, so when you're depressed and you're sad, what's another word for that? You guys got it. This first period was all over the place. They gave me all kinds of interesting things. You guys are on it. All right, when you're sad, you're down, right? When we're depressed, we're down. Okay. So the angle of depression is the down angle, but we have to be very, very careful in that. It's the elevation one's usually easy to see. The depression one is harder, okay? So let's write the official definition. That means down, okay? So it's the angle by which an observer's, it's almost the same definition, line of sight must be depressed from a horizontal to the point observed. PT is point. Wondering what who said, Amy? Wondering what who said. All right. First period. Oh, I can't remember, but they gave me all. I must have gotten like 10 words before I got down. So they were all over the place. They repeated the word depressed. I remember that being one of them, and we need something else besides that. So, all right. So here's the catch in this one. Okay, so don't write this next thing down. So wait till I tell you to write again. Okay. We are not talking about this there. That is not the angle of depression. All right. Your angle of depression has to come down from a horizontal. So let me redraw. So the angle of depression from the horizontal, there's the horizontal line I am coming down. Okay, that's the angle of depression. Hopefully you're noticing and recognizing something. Do you guys remember the Z from parallel lines in geometry? Aren't those alternate interior angles? What do you guys remember about alternate interior angles? You guys remember what the relationship is? Nothing? Thanks, Matthew. All right. They're the same. They're equal, okay? Isn't it great when I pull out the obscure geometry that we never use for anything else, right? I was talking with a family friend / principal in the district this morning, talking about math, and I was saying that geometry is probably, even though it's our most practical, we don't use it in hardly of any of our other classes. So basically these guys are the same. So you'll know that these are congruent angles in here. So when I have the angle of depression, I can move it down into the angle of elevation for my triangle. All right. Okay, you guys ready for this? You just watch Mrs. Ballard draw stuff. So when I first transferred over to Tockwitz as a teacher, they only had one section of math for me to teach. So I had to teach some elective classes. And one of the elective classes I taught was multimedia, believe it or not. So I taught like Photoshop and Illustrator and some of those Adobe products and PowerPoint, because that's what we had at that point. Google wasn't big yet back then. And it was technically an art class. So they let me be an art teacher. Wait till you see my artistic skills here. Okay. So we've got a parasailer attached to a boat. All right, you guys ready to see my fantastic boat? Okay, here it comes. All right, here's my boat. There we go. There's my boat. That would be a boat that a parasailer would be attached to, right? Okay. Then we need some water for the boat. So here's the water for the boat. All right, and then we need a parasailer. Okay, so let's draw a parasailer. Here they are. Okay, and then he needs the parasail. So here's the parasail. There we go. And he has to be attached to the boat. And I'm going to attach him to the bottom of the boat to make our math easier. There we go. Isn't that fantastic? Aren't I a great artist? Can you believe they let me teach art? Okay. Then it says, let's see. The parasail is attached to a boat with a rope 300 feet long. So I'm going to label that 300. The angle of elevation from the boat to the parasailer, so from the boat to the parasailer's angle of elevation, the angle up is 48 degrees. Estimate the parasailer's height above the boat, and we would assume that this height is the same as the height above the boat. Do you see the triangle being formed there? That's the important part, is $300 million art. Yeah. Isn't that great? Okay. I can sign it and hand it out later if you'd like. Okay. I'll give it to you for free, even the $300 million art. So what we're really looking for is this X here, and your goal of the picture is to find the triangle in it. All right. And then once we have the triangle, we look at the parts of the triangle we have to determine if it's sine, cosine, or tangent. And it is possible to also use the other three. You could use cosecant, secant, and cotangent as well. Okay. It just depends on whatever floats your boat. Okay. No pun intended. All right. This is the opposite, and this is the hypotenuse. So which ratio do I have, sine, cosine, or tangent? Tell me in the chat. What do you guys think? All right, we definitely have sine there. Good job, everybody. So sine of 48 equals x over 300. All right, and again, same process as before. I'm going to multiply that 300 over. So 300 times the sine of 48 equals x. All right, and then we're going to go into our calculator, right? I'm going to pull my calculator out again. Okay, so 300 times the sine, it was 48, right? Ooh, that's not the button, I wanted that one. Sine of 48, perfect. Okay, so we get that it is 222.943. 222.943, and we would want to label it at least in feet because it is a word problem and we typically label our measurements in word problems. All right, that's probably the most entertaining picture we have because my other ones, the problems aren't quite as exciting as the parasailer. But who knows? We'll see what else is coming. All right, I'll leave it there a few more seconds and then we'll move on to the next one. Okay. From a point on the ground, 28 feet from the base of the flagpole, the elevation to the top of the flagpole is 63 degrees. Estimate the height of the flagpole. Okay, so I've got a flagpole. Okay, I've got a point on the ground. The angle of, so I'm going to actually draw a line there because I've got the point on the ground. There's my right angle. Angle of elevation to the top of the flagpole. So my angle going up from the horizontal is 63 degrees. We're 28 feet from the base. We need to estimate the height of the flagpole. What leg is the X on? Can you all tell me that? What leg is the X on? All right, perfect. We know it's on the opposite leg. So when I have opposite and the 28 is on the adjacent leg, which ratio do I have there? Sine, cosine, or tangent? Jose is on it today. Nice work. All right, we're looking at tangent. Nice job, everybody. So we've got the tangent of 63 equals x over 28. Again, we're going to multiply. 28 times the tangent of 63 equals x. Okay, I'm going to put it in my calculator one more time. Okay, let's see, calculator. So 28 times the tangent of 63. So that would be 54.953. I'm not sure we have a 54-foot flagpole at Topwoods. That seems like a lot of feet for a flagpole. This is how you can tell Mrs. Bell I made up the numbers. So 54.953, and it's still in feet. Maybe if you measured the one from the base of where the ground is for the stadium up to the top of the flagpole in the stadium, maybe we have a 53-foot flagpole there. I don't know. That's kind of pushing it. It's not really the height of the pole then. All right. We've got another boat. Who's ready to draw another boat? We excited? I know I am. All right, let's draw a boat. They didn't ask me to draw a car in any of them. My car is pretty good. Okay, here comes the boat. We'll make it a green boat this time. There's the boat. Oh, I drew it really big. Probably too big. So this is not drawn to, I gotta erase that because it's gotta go with a cliff. We gotta make it smaller. There we go. There's my boat. Okay, boats always are in water. There we go. The water level is 20 yards below a cliff. All right, here's my cliff. There we go. So it says it's 20 yards below the cliff. So this is 20 yards. If the angle of depression from the cliff to the boat is 37 degrees. So we've got our angle of depression. Oh, we got to be careful. So remember, my angle of depression is going to come down from the horizontal. This is the 37 degrees. Okay, that's a 90 degrees. So what is the angle of depression the same as? You guys tell me, what is the angle of depression the same as? It's the same as what angle? There we go. Matthew, do you need a nap today? You seem to be a little off your game. All right, is it gonna, are you taking a nap before you do the puzzle? All right, I wish I could do a puzzle. All right, I think I need a nap today too, and I haven't even done that much today. All right, it is the same as the angle of elevation. Thank you, Jose and Alondra. Okay, so we're gonna put it down here, 37 degrees. All right, it says, how far is the boat from the cliff? So here's my question on this one. Where do I put the X? Is the X gonna go on the water or the hypotenuse? Can you guys tell me, where does my X gotta go to figure that out? Am I going on the water or the hypotenuse? I wanna hear from everybody because I'm only hearing from a few people right now. Water or hypotenuse? Okay, it's looking like you guys are understanding. It's got to go on the water. Perfect. Okay. I'm not going to give you which sides are which this time. I'm not going to set it up for you. I want you to know from you, which trig ratio am I going to use on that one? So what do you guys think? What trig ratio should I be using with the information I have? All right, I've got a bunch of people saying tangent. Tangent, though, isn't the only one. If you think of another one that I could use, you can put it in the chat. So let's start with tangent. So I'm going to say the tangent of 37 equals my opposite 20 over my adjacent x. And you correctly have identified tangent. Tangent works for us, okay? So I'm going to multiply by x. And then what do I need to do to move the tangent of 37 to the other side? So what do I need to do to move that? Can you guys tell me in the chat? I want to hear from everybody. What operation do I need to do to move that tangent? Logan, I think you need to revise your answer. Right now we are under multiplication. There we go. We've got to divide it to the other side. Okay. So we've got x equals 20 divided by the tangent of 37. Okay. So let's do that in our nice little calculator here. Ooh, come back. So it is the 20 divided by tangent of 37. So 26.541, right? Because there's an 8 there. So 26.541. Now, I want to show you something else that you could have done. Because I know you're teenagers, and sometimes we like to do things the lazy way. All right? So trust me, I'm still there. I'm not a teenager, but I am lazy sometimes. You should see how untidy my house is. So it's not pretty, but I do have 2 small children that we call the bumblebees because they pick stuff up and like drop it everywhere. It's like pollinating. They pollinate the whole house. All right, so that doesn't help to the tidiness of the house. It's hard to keep up with them, and they work like a team. It's a little bit ridiculous. All right, so the other thing I could have done is I could have done the cotangent of 37. So watch this, and this is the lazy, kind of the lazy way. Because when I do the cotangent would be adjacent over opposite. So I would get x over 20. So instead of having to do the multiply and then the divide, I just get away with the multiply, okay? I have the spirit, all right, of being lazy and not cleaning up after my 2 little children. All right, 20 cotangent of 37. So look at the answers. See how they came out to be the exact same. Okay. Yeah, team spirit. We try. We do try. Like this, the family room where we're all in there the most, we try to get that tidy, and then the rest, it is what it is. And I swear, every time I had a child, I've got 4. The laundry doesn't just multiply by like 1/6 around here. Every time I had a child, it doubled for every child. Laundry is ridiculous. Okay. So, but everyone leaves me alone when I'm doing laundry. So I do like to do the laundry. I just don't like to fold the laundry. But yeah, nobody wants to be up there and help. So my husband's wonderful though, and he does the dishes. So most of the time. I do pitch in there once in a while, but he does most of the dishes. So I hated doing the dishes as a kid. So that's my least favorite chore. All right. You are measuring the height of your school building. So guess what we get to do now, you guys? We get to draw a self-portrait. All right. Everybody draw a self-portrait because it's you in the picture. All right. I'm going to draw a self-portrait too. You ready? Here we go. Although I don't wear dresses. If I could draw leggings, I would put leggings on that. So there's my self-portrait. That's my picture of a girl. Okay. All right. Self-portrait. Okay, you have a school building. So here's my school building. THS. There we go. If you want to put if you want to make it my room, you can write room 727 there. There we go. There's our school building. I'm not sure it's drawn to scale. All right. Then it says you stand 25 feet from the base of the school. So I am standing here 25 feet. Okay. It looks like I've got a nice right angle. The angle of elevation from the point on the ground to the top of the school is 62 degrees. Estimate the height of the school to the nearest foot. All right. Sine, cosine, or tangent, everybody. Sine, cosine, or tangent. Tell me in the chat, what should we use? Or I suppose we could do cotangent, cosecant, or secant, right? Yuya's excited about this one. All right, so it is tangent. Oh, Amy is excited too. She likes tangent too. Okay, so yay, tangent. Tangent of 62 equals my opposite x over my adjacent 25. Okay. And so we're going to multiply both sides by 25. I'm going to be a little bit lazy on this one. When I put this in my calculator, 47.018. But there's a catch in here. Do you guys notice this? Normally I say 3 decimal places, but the catch is estimated to the nearest foot. So the nearest foot would be 47 feet, right? If it didn't say that, 3 decimal places. Okay. All right. There is a homework assignment. I think it's like 3 problems. Okay. But remember, you have to do this plus your asynchronous. You also should be watching the video on the vocabulary. Okay. And I think it goes up through example 3 on the next set of notes. All right. I'm going to do the joke of the day. And then we are going to be done in just a few minutes early, right? So let me find my joke of the day.